Assalamu alaikum. Today we are doing further integration of trigonometric functions. Okay, and whenever we have to integrate sine square x or cos square x, we make use of the double angle formula which we have already learned. These are the three double angle formulas. Okay, I'm making use of this one. Okay, so we had cos of 2x equals to cos square x minus sine square x. Now, if we all know the basic identity, the first identity, which was sine square x plus cos square x equals to 1. Okay, sine square x is 1 minus cos square x, and cos square x is equals to 1 minus sine square x. Okay, so if I want to find out cos of 2x in terms of cos square x overall, so I'm going to substitute sine square x by 1 minus cos square x. So if I just want to write cos of 2x equals to cos square x minus sine square is 1 minus cos square x, which is cos square x minus 1 plus cos square x, which is 2 cos square x minus 1, which is here. This is the formula. Now if I want to write down cos of 2x in terms of sine square x only, then the same basic formula I'm writing it here, and I will be substituting in place of cos square x 1 minus sine square x. So it will be 1 minus sine square x minus sine square x, which will become 1 minus 2 sine square x. Now from here we can make cos square x the subject. Okay, I'm doing it here. Cos of 2x equals to 2 cos square x minus 1. Okay, let me do it here on this side. Okay, so cos of 2x equals to 2 cos square x minus 1. If I make cos square x the subject, it will become cos of 2x plus 1 divided by 2. Okay, so cos square x equals to cos of 2x plus 1 divided by 2. You can even write it like this, 1 upon 2 cos of 2x plus 1. Okay, from here, if I want to make sine square x the subject, I will write 2 sine square x equals to 1 minus cos of 2x. Okay, so sine square x is going to be 1 minus cos of 2x divided by 2. So I can write it like this, 1 upon 2 into 1 minus cos of 2x. Okay, so whenever we have to do integration of sine square x, in place of sine square x you can always substitute this, in place of cos square x you can always substitute this. Now if you have to integrate tan square x, we know the identity 1 plus tan square x equals to sec square x. So if I want to make tan square x the subject, it will be sec square x minus 1, and we know the integration of sec square x is tan x. Okay, because the differentiation of tan x is sec square x. So whenever you have to make integrate tan square x, you can always substitute in place of tan square x sec square x minus 1, and then you can go ahead with the integration of this is going to be integration of sec square x is tan x minus x. Okay, starting with, okay, I'm just highlighting what will be useful for us. Whenever you have to substitute sine square x, you can always substitute it by half into 1 minus cos of 2x, or simply 1 minus cos of 2x divided by 2. And whenever you have to integrate cos square x, you can substitute it by 1 plus cos of 2x divided by 2. Whenever you have to integrate tan square x, it will be tan square x minus 1. Okay, starting with the first question here, the A part, it's sine square x. So in place of sine square x, I can always substitute here. If you look here, half into 1 minus cos of 2x. Okay, so I can write half outside, 1 minus cos of 2x. If you want, you can even keep half inside, but since it's a constant, it's better to take it out, dot dx. Okay, so I can just write keep half inside, and then I can start integrating. Integration of 1 is x, and integration of cos of 2x is sine of 2x divided by 2. Okay, since I'm doing integration in this step, I have to put the bracket now, not the integration sign. Okay, So integration of cos of 2x is going to be sine of 2x divided by 2. This is the answer. So when now you multiply half by the whole bracket, so you get half x minus 1 upon 4 sine of 2x plus c. Okay, this is the first answer. Now let's do this one. It's 3 times cos square 2x. If I want to integrate this, I can take out 3 first, write down cos square 2x dot dx. Now cos square x can be substituted by this. I'm just copying this down. Okay, if cos square x can be substituted by this cos square 2x, if I put 2 here, I will have to put 4 here because I'm doubling the angle on this side, so I have to double the angle on this side as well. So I can write cos square 2x will be 1 upon 2 into 1 plus cos of 4x. Okay, so if I have to integrate this, in place of cos square 2x, I can simply write this half into 1 plus cos of 4x dot dx. Now this 2, because it's a constant, I can take it out. It will become 3 upon 2. Now I have to integrate 1 plus cos of 4x dot dx. If I have to integrate this, I will integration of 1 is x, integration of cos is sine x, so sine of 4x divided by 4. Okay, so I'm just going to multiply 3 upon 2 by x, then 3 upon 8 sine of 4x plus c will be the final answer to this question. Okay, moving on to the next one, sine of 4x. Okay, so I'm just going to take this formula. This is the formula for sine square x. If I square it, okay, yeah, if I square it, I have to square both the sides. Sine square x squared is going to give us sine 4x. Okay, this if I square this, it's 1 minus cos of 2x. 1 upon 2 square is 1 upon 4, and 1 minus cos 2x squared. This will become 1 upon 4 outside. Okay, so 1 minus 2 cos 2x plus cos square 2x. Okay, so I'm writing sine of 4x. In place of sine of 4x, I'm just copying this whole thing. Sine of 4x is equal to 1 upon 4. I'm keeping it outside. 1 minus 2 cos 2x plus cos square 2x. Now cos square 2x, because we know cos square x is actually equal to 1 plus cos of 2x divided by 2. I've taken it from here. Cos square x is 1 plus cos of 2x divided by 2. Okay, so if I have to make it into cos square 2x, now look here. If I want to double the angle here, I will have to double this angle as well. Okay, so it will become cos. I can replace this by this whole thing. Now it's 1 upon 4, 1 minus 2 cos 2x plus, in place of cos square 2x, I'm writing half plus cos of 4x divided by 2. Half plus cos of 4x divided by 2. Now I have to integrate this whole thing. Let's start with the integration process now. 1 upon 4 stays outside only. Integrating of 1 is going to be x minus integration of cos 2x is sine 2x, so minus 2 sine 2x divided by 2 plus integration of half is half x plus cos of 4x divided by 2, so 1 upon 2 sine of 4x divided by 4. Okay, since I was doing integration, I should have put the bracket here. It's 1 upon 4 outside the bracket. X plus half x is 3 upon 2x minus 2 and 2 will cancel out. Sine of 2x plus 1 upon 8 sine of 4x. Okay, you can multiply 1 upon 4 by all of it, so it will become 3 upon 8x minus 1 upon 4 sine of 2x plus 1 upon 32 sine of 4x plus c. This is the final answer to this question. Okay, The next one is this one. Find the exact value of integration of, you've got the boundaries here, so you don't need to put C, 5 tan square x. Now, as I told you that whenever you have tan square x, you will use the identity 1 plus tan square x equals to sec square x. Okay, so tan square x we know is equals to sec square x minus 1. Okay, so I'm keeping 5 outside. You can always take the constant outside. Okay, in place of tan square x, I'm writing sec square x minus 1 dot dx. Now I'm going to integrate this. We know the differentiation, if y equals to tan x, dy by dx is sec square x. So that means integration of sec square x is going to give you tan x plus c. Okay, so integration of sec square x is tan x. Integration of 1 is x. Okay, you have to multiply. You have to put the boundaries of pi by 4 and 0 now. Let 5 be outside. Tan of pi by 4 minus pi by 4 minus tan of 0 minus 0. Okay, this is tan of pi by 4 is 1 minus pi by 4 minus tan of 0 is 0 and then a 0. Okay, so it's 5 minus 5 pi by 4 is the final answer. You wanted the exact value, so let it be like this only. Okay, 5 minus 5 pi by 4, you can take out the LCM if you want. 5 4 times is 20 minus 5 pi. Okay, so you can leave it like this. The next question number 3, question number 1 now from the exercise. Let's do this one. Okay, the B part, 4 cos square x upon 2 dot dx. Okay, we know that cos square x, if you have to integrate this, okay, we know cos square x is 1 plus cos of 2x divided by 2. So if it is x here, there's a 2x here. If I want to make it x upon 2, cos square x upon 2. Okay, so here this angle will be halved because this is being halved here, so this angle will be halved. The rest will remain the same, 1 plus cos of x divided by 2. Okay, so I'm just writing 4 outside. In place of cos square x upon 2 dot dx, I'm substituting it by 1 upon 1 plus cos of x divided by 2 dot dx. I'm shifting this 2 also outside, so it become 4 upon 2, which is 2 only. Now I'm going to integrate 1 plus cos 2x. Sorry, 1 plus cos of x dot dx. Integration of 1 is x and integration of cos of x is sin x. Okay, so I will have to multiply 2 by this whole bracket. So it's 2x plus 2 sin x plus c. This is the answer to this part. Okay, if I do say this one, sin square 3x, the c part. Okay, sin square 3x. We know that sin square x is 1 minus cos of 2x divided by 2. Let's just go back and see again. Sin square x is 1 minus cos of 2x divided by 2. Okay, now if I want a 3 here, that means I'm multiplying this angle by 3, so I will have to multiply this angle by 3 too. So it will become sin square, I'm writing sin square 3x will be 1 minus cos of 2 into 3 is 6x divided by 2. So 1 upon 2 I'm taking outside and I'll write 1 minus cos of 6x dot dx. So I have to integrate this. Integration of 1 is going to be x. Integration of cos of 6x is going to be sine of 6x divided by 6. Okay, so multiplying it by half will give me half x minus sine of 6x divided by 12 plus c. This is the answer. Okay, moving on to question number say the E part. It's 6 tan square 3x. Okay, we know tan square x can be substituted by 1 minus sec square x minus 1, because this is the identity. So tan square x is going to be sec square x minus 1. Okay, I'm taking 6 outside. I'm writing tan square 3x here dot dx. Now if I want to multiply this by 3, I will have to multiply this also by 3. So tan square 3x is going to be sec square 3x minus 1. Okay, so I'm writing, in place of tan square 3x, I'm writing sec square 3x minus 1 dot dx. Now I'm going to start with the integration process. Integration of tan square 3x is going to be, sec square 3x is going to be tan of 3x divided by 3 minus integration of 1 is x. Okay, when I multiply 6 by this whole bracket, it will become 2 tan of 3x minus 6x plus c. This is the final answer to this question. Okay, now I'm doing the f part, which is cos of 4x. Okay, we know cos cos square x is 1 plus cos of 2x divided by 2. If I make it into cos of 4x, it will become, you have to square both sides, square the numerator as well as the denominator. So it will become 1 plus cos of 2x the whole square divided by 4, which is 1 plus 2 cos 2x plus cos square 2x upon 4. Okay. Okay, so, and we know cos square 2x can be replaced by, we know that cos square x is 1 plus cos of 2x divided by 2. So cos square 2x, when I'm doubling the angle here, I will have to double the angle here as well. Okay, so I'm just copying it. 1 upon 4 I'm keeping outside. In place of cos 4x, I'm writing 1 plus 2 cos 2x, plus in place of cos square 2x, I'm writing this whole thing. So it's half plus 1 upon 2 cos of 4x. Okay, I've done this question previously a few minutes back. 1 plus half is 3 upon 2. So I can write 3 upon 2 plus 2 cos 2x plus half cos 4x dot dx. Now I'm going to start with the integration process. 1 upon 4 integration of 3 upon 2 is 3 upon 2x. Integration of cos of 2x is sine 2 sine 2x divided by 2 plus 1 upon 2 cos of 4x is integration is sine of 4x divided by 4. Okay. Okay, 1 upon 4 stays outside. 3 upon 2x plus sine of 2x plus 1 upon 8 sine of 4x. Finally, you can multiply 1 upon 4 by the whole thing. 3 upon 8x plus 1 upon 4 sine of 2x plus 1 upon 32 sine of 4x. Okay. Okay. Now we move on to question number 2. Find the value of, if I would like to do question number, say, the E part and the F part. Okay, so E part here. If 4 sine square x, 4 I can take out outside, and in place of sine square x I can write 1 minus cos of 2x divided by 2 dot dx. Okay, the boundaries are pi by 6 and 0. I'm writing it here. I'm going to integrate this. Acha, this 2 also I'm putting it out, so it's 1 minus cos of 2x, the integration dot dx with pi by 6 and 0 here. Okay, 2, I'm going to start integrating now. Integration of 1 is x minus integration of cos of 2x is sine of 2x divided by 2. Okay, and now the boundaries are pi by 6 and 0. If I multiply both of them by 2 firstly, I'll get 2x minus sine of 2x. Now I have to apply the boundaries of pi by 6 and 0. 2 into pi by 6 minus sine of 2 into pi by 6. This is the first bracket, minus 2 into 0 is 0, and sine of 0, okay, that is also going to give us 0. When I simplify, I'm getting a pi by 3 minus sine of pi by 3. This is the final answer to this question. You can either leave it like this, or you can solve it and give the answer in decimals. Okay, I'm doing the F part now. Tan square 2x, we know that tan square x is equals to sec square x minus 1, and tan square 2x is going to be sec square 2x minus 1. Okay, so I'm writing, in place of tan square 2x, I'm writing sec square 2x minus 1. Okay, with the boundaries pi by 6 and 0. Now I'm going to start with the integration. Integration of sec square 2x is going to be tan of 2x divided by 2 minus integration of 1 is x. Now putting the boundaries here, pi by 6 and 0. Okay, so tan of 2 into pi by 6 upon 2 minus pi by 6, the first bracket, minus tan of 0 minus 0 would be giving you a 0 only. So no use writing down the second bracket. Okay, it's 2 times pi by 6 is pi by 3. Tan of pi by 3 is root 3 upon 2 minus pi by 6. This is the final answer. Even if you want to take out the LCM, you can. It will become 3 root 3 minus pi. Okay, so whatever, either this or this will be acceptable. Moving on to question number 3. The first question, it says cos square x minus 1 upon cos square x dot dx. So I'm doing the first one. Okay, let's do this question. In place of cos square x, we can write down the double angle formula, substitute for this, and 1 upon cos square x is sec square x. So let us do it this way. Pi by 6 and a 0. In place of cos square, I know I can write 1 plus cos of 2x divided by 2, and in place of cos square x, I can write sec square x dot dx. Now let's integrate it. If I just separate this, like half plus cos 2x upon 2, okay, I can write it a half plus cos 2x divided by 2 minus sec square x dot dx, and I have to integrate it pi by 6 and 0. Okay, integration of half is going to be half x, plus integration of cos 2x is sine 2x divided by 2. So there was already a 2 out in the denominator, so 2 into 2 is 4, minus integration of sec square x is going to be 10x. I have to put the boundaries of pi by 6 and a 0. Okay, half into pi by 6 plus sine 2 pi by 6 divided by 4 minus tan of pi by 6 minus, now if I put the boundaries of 0, it will be a 0 plus sine of 0 minus tan. Okay, the whole thing will be 0, so no use writing it down. Okay, then it's going to be 1 upon 12 pi plus sine of pi by 3, sine of 60 is root 3 upon 2. Root 3 upon 2 divided by 4. Okay, this will sort it out. Tan of pi by 6, it's 1 upon root 3. Okay, so it's pi by 12 plus root 3 upon 2 multiplied by 1 upon 4 is root 3 upon 8 plus 1 upon root 3. Okay, so if you want, you can simply take out the LCM and solve it, or you this thing 1 upon root 3 can also be written as 1 upon root 3 times root 3 upon root 3 can be written as root 3 upon 3. Okay, so I'm writing root 3 upon 3 here. 3 upon 3. You can write down this as the final answer, or you can actually add these two, or take out the LCM, the whole thing together, whatever. So you can even give this as the final answer. If you want to take out the LCM of the whole thing, LCM of 12, 8 and 3 is going to be 24. 12 2 times, so 2 pi, plus 8 3 times, 3 root 3, plus 3 8 times, so 8 root 3. This can become 2 pi plus 11 root 3 upon 24. This is the final answer. You can give it like this also. Okay, then I'm moving on to question number, say, the B part. It's cos square x plus sine of 2x. So in place of cos square x, I'm writing 1 plus cos of 2x divided by 2. In place of sine of 2x, I'm writing 1 minus cos of 2x divided by 2. And the boundaries are pi by 6 and 0 dot dx. Okay. Okay, start continuing with it. Okay. If I take out 2 as common, or 2 as the LCM, okay, I'll be left with 1 plus cos of 2x plus 1 minus cos of 2x dot dx. This 1 upon 2 I'm taking out as common here. Firstly, I'm writing pi by 6 and 0 here. This 2 I'm taking out as common here, so I'm writing a 1 upon 2 here. 1 upon 2, and I'm going to start with the integration process. Integration of, let me simplify it first, because 1 plus 1 gives you 2. So it's going to be pi by 6 and a 0. The boundaries 2 plus cos 2x minus cos of 2x. Cos 2x minus cos 2x is cancelling out, so you're just left with 2 dot dx. So integration of 2 is going to be 2x. Now pi by 6 and 0. I'm getting rid of 2. So pi by 6 minus 0. The answer is going to be pi by 6 for this part. Okay. Moving on to the C part then. Okay, if I simplify it, I will write pi by 4 0 here. If I apply the formula onto this, 2 sine x the whole square plus 2 times 2 sine x cos x plus cos x the whole square dot dx. Okay, so it becomes 4 sine square x plus 4 sine x cos x plus cos square x pi by 4 and 0 dot dx. Okay, so if I start with the integration process, firstly, before starting, you will have to substitute sine square x by the double angle substitute of it, which is 1 minus cos of 2x divided by 2. Okay, plus 4 sine x cos x. I can leave it like this, and I will use the product law here. As far as cos square x is concerned, I can write 1 plus cos of 2x divided by 2 dot dx here. This will cancel out. So you have 2 minus 2 cos 2x plus 4 sine x cos x plus 1 upon 2 plus cos of 2x divided by 2 dot dx. Okay, now let's add this 2 and this half. You get 5 upon 2. 5 upon 2 minus 2 cos 2x plus 4 sine x cos x plus cos 2x divided by 2. Okay, now one thing. Negative 2 cos 2x plus half cos 2x. Negative 2 plus half is negative 3 upon 2. Okay, so I'm just adding them up together. So I'm going to get a 5 upon 2 minus 2 plus half is minus 3 upon 2 cos of 2x plus 4 sine x cos x. And the boundaries are pi by 4 and 0. Okay, let's start with the integration process now. Okay, 5 upon 2, the integration is going to be 5 upon 2x. Integration of cos of 2x is sine of 2x, so minus 3 upon 2 sine of 2x divided by 2. And as far as this is concerned, okay, I'm talking about this. So you can use the product law. So first, I'm using 4 sine x as one function and cos of x as the second function. So first function as it is, 4 sine of x Integrate the second one. Integration of sine cos x is negative sine, positive sine x, plus second as it is. Oh, okay, I'm so sorry. I started differentiating by mistake. Okay, now we know the double angle formula, which is sine of 2a, which we are using for the first time in these questions right now. Sine of 2a was 2 sine a cos a. I'm writing it here with red. Sine of 2a is equals to 2 sine a cos of a. Now, in terms of x, if you want to write sine of 2x equals to sine of 2 sine of x cos of x. Now, if I want, instead of 2 sine x cos x, if I want 4 sine x cos x, that means I'm multiplying this side by 2. So I have to multiply this side also by 2. I'll get 2 sine 2x. So I can write 2 sine 2x in place of 4 sine x. Okay, now I'm going to start with the integration process, pi by 4 and 0 in the next step. Okay, let's do that. Integration. Okay, I'm so sorry. Here I'm just reverting back to the normal thing because I don't want to start integrating from this step. So I'm writing 5 upon 2 minus 3 upon 2 cos of 2x plus 2. Instead of this, I've written this now. Now I'm going to start with integration in this step. This is going to become 5 upon 2x minus 3 upon 2. Cos की integration is sine of 2x divided by 2. So it will become 2 here. Plus integration of sine is negative cos. So it's going to be negative 2 cos 2x divided by 2. So this and this will cancel out. Okay. So I was doing integration. So I have to apply the boundaries of pi by 4 and 0. Okay. So I'm just doing it here, applying the boundaries. 5 upon 2 into pi by 4 minus 3 upon 4 sine of 2 pi by 4 minus cos of 2 pi by 4. This is the first bracket which I have. And the second one, this is going to give me a 0. Sine of 0 is 0. Cos of 0 is a 1. Cos of 0 is a 1. So minus 1 in the second bracket. Okay, let's solve this. It become 5 upon 8 pi minus 3 upon 4 sine of pi by 2. Pi by 2, sine of pi by 2 is a 1 minus 2 1 times 2 to 2 times. Cos of pi by 2 we know is 0 plus 1. So it's 5 upon 8 pi minus 3 upon 4 plus 1. Okay. So 5 upon 8 pi plus half. That means if you want you can take out the LCM. 5 pi plus 2 will be the final answer for this question then. Okay. Let me do the E part. Okay, if I divide both the terms by cos square x, what will I get? It's pi by 6 and 0 here. 1 upon cos square x is, I'm just writing it separately first, cos 4x upon cos square x dot dx. 1 upon cos square x is sec square x, and cos 4x upon cos square x will give me cos square x only dot dx. Okay, pi by 6 and a 0 here. Sec square x, it's easy to integrate, so I'm writing sec square x as it is. Cos square x, I'm writing 1 plus cos of 2x divided by 2 dot dx. Now I can start with the integration process. Integration, I can separate it first. Sec square x plus 1 upon 2 plus half cos of 2x dot dx. Sec square x, the integration is going to be 10x plus half, integration is going to be half x plus half cos 2x. Integration of cos is positive sine 2x divided by 2. So half sine 2x divided by 2. Okay, so it has become sine of x plus half of x plus 1 upon 4 sine of 2x The boundaries are pi by 6 and 0. Pi by 6 and 0. So you can write tan of pi by 6 plus half into pi by 6 plus 1 upon 4 sine 2 pi by 6. This is the first bracket. Tan of 0 is 0. Half into 0 will also give you 0. This will also give you. So no use putting this. Let's simplify this. Tan of pi by 6. Tan of 30 is 1 upon root 3 plus pi by 12 plus 1 upon 4 sine of pi by 3. Sine of pi by 3 is root 3 upon 2. Okay, so if we take out the LCM, okay, first of all, I'm writing this as root 3 upon 3, root 3 upon 3 plus pi by 12 plus root 3 upon 8. LCM is going to be 24. 3 8 times 8 root 3 plus 12 2 times 2 pi plus 8 3 times 3 root 3. It will be 11 root 3 plus 2 pi upon 24. This will be the final answer to this question. Okay, this brings us to the end of this video. Hope you must have learned something. Thanks a lot for watching it.